So good? Everybody got that? Because I have this y-intercept that says I cross the y-axis at 5. And since I was at 2, to get to the y-axis, I had to go over 2. So general form is that f of x is equal to ax squared plus bx plus c. Remember when you use quadratic formula? Remember, it's still true that a cannot be equal to 0 because if a is equal to 0, it's not quadratic anymore. Right? We call that general form. The same things are true here. If a is less than 0, it's going to open down. If a is greater than 0, it's going to open up. But now the vertex is a little bit different because this isn't in that nice standard form where the vertex is just sitting there. But there is a shortcut. The vertex can be found by using the first piece of the quadratic formula. Negative b over 2a. Remember where a is the number in front of the x squared term, b is the number in front of x, and c is the constant. So I can just put those numbers together. That's my x coordinate of my vertex. Now the only way to find that is to actually plug that back into the equation. And find the y to go with that x. The axis of symmetry, remember, is what? Didn't change. It's x equals, well, it's not h anymore in this formula. It's what? Negative b over 2a. That is h, right? This is my x coordinate, however I found it. It was h in the other one because it was in that form, in that standard form. Same thing is true about the x-intercepts. I'm still going to take f of x, and I'm going to set it equal to 0. And to find the y-intercept, I'm going to find f of 0. Okay, everything's the same except how you find the vertex. You do have to work a little bit harder to find the vertex when it's in this form. Checkpoint 3. So we want to graph. We did checkpoint 2, yeah. So if you'll look, see there's no h there. It's not sitting there. So what do I know first of all? It opens down because a is negative. To find my vertex, I got to take the opposite of b divided by 2a, which is negative 4 over 2 times negative 1. Take the 4 here and the negative 1 here. So to find my vertex, I've got negative 4 over negative 2, which is 2. So the x-coordinate of my vertex is 2. So I already know my axis of symmetry, right? Yes? How do I find the y value to go with this 2? Plug it back in for x. So the other piece of finding the vertex is you take the x-coordinate and plug it into the original equation. So 2 squared is 4. And I want the opposite of that, so negative 4 plus 2 times 4 is 8 plus 1. So it's 5. There's my vertex, 2, 5. My x-intercept, 0 is equal to negative x squared plus 4x plus 1. That's not going to factor nicely, right? Even with bottoms up, that's going to make that negative 1, and there's no two numbers that multiply together to give you negative 1 that add together to give you 4. Not nice whole numbers anyway. So might as well put it in the quadratic formula. Remember, the quadratic formula says that x, which is the x-intercept, is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So I've got the opposite of b plus and minus the square root of 4 squared minus 4 times negative 1 times 1 divided by 2 times negative 1. Just taking the a, the b, and the c and plugging it into the formula in the appropriate places. You did that last chapter, right? So x is equal to negative 4 plus and minus the square root of 16 plus 4, which is 20, over negative 2. And since we are graphing, plotting this on a coordinate system, I don't have to worry about keeping an exact number. So you can put this in your calculator and get an approximate value, unlike the way I was making you do it before to get the exact value. So since we're drawing the graph, I do need a decimal approximation. I don't need it written as an exact answer. But if we did do it as an exact answer, 4 squared 16, that's plus 4. So that's 4 times 5, right? So that simplifies into 2 times the square root of 5. Yes? So if you were trying to get your exact answer, it's 2 plus and minus the square root of 5. But I need a decimal approximation. So what's 2 plus the square root of 5? Is it about 4 point something maybe? Thank you. And what's 2 minus the square root of 5? All right, negative 0.2. And I need my y-intercept. So if I'm finding the y-intercept, remember I'm finding f of 0. So I get negative 0 squared plus 4 times 0 plus 1. So what's my y-intercept? 1. Nice thing is the y-intercept is very easy in this form. There are a few pluses. So I take this information. What was my vertex? 2, 5. And what were my x-intercepts? Negative 0.2, right? Be approximately right there. See why I said it doesn't really matter? We're just drawing the graph, right? And what was the other one? 4.2? About? That's about right there. And I should be crossing at 1. Oops, I missed it a little bit. Okay? That's all there is to it. Objective 3. We also want to be able to determine minimum and, oh, it wouldn't be and, or maximum values. Now, why did I take the word and out? If I'm talking about a parabola, how many of these do I have? Just one. It's either a max or a min, right? Now, how can you tell, just by looking at a graph, whether it's going to have a maximum value or a minimum value? Anybody got an idea? If it opens up or down, that's exactly right. So what am I looking at to tell if it opens up or down? It's where? The number that's multiplied by the x squared term is the one I'm looking at, a, right? So if a is a positive number, greater than 0, it opens what? Up. We've been saying that over and over. Y'all been telling me that. Y'all know this. So if we know it opens up, then what am I going to have for the vertex? Okay, it opens up. It opens up. That's a minimum. The vertex will be a minimum point. If a is less than 0 or a negative number, we know it opens down. And if it opens down, that means the vertex gives me a maximum. Okay? The big thing that people have trouble with here is they have two different questions they ask about minimums and maximums. They ask, what is the min or max? And they ask, where is the min or max? Okay? Those are two different questions. They're both still talking about the vertex. Both of these answers I get from the vertex. But what is the y value? Where is the x value? Okay? When it asks for what is it that they're asking for the y value of the vertex. When they want to know where did it happen, they want to know what's the x value. Okay? That's the big thing you need to know about the minimum or maximum. Alright, so